I made a mistake, sorry. This one is c2 times exponential of 2x. Okay, this one got to be this. Then we do this again. I put 2 up there, 2 here. So this one I would get 2 and 2. Right? And this one, 2 there and 2 here. We would get 4, right? Okay? Uh, oh, this one too. Sorry. But after we dip it, we would get 4 there. And then this one got to be 4 here and 2 there. And this is to the power 2x. Right? Is that 0? The first term then cancel out. This one 4 minus 2 minus 2, that is equal to 0 now. So from this I would say that we can say that b is equal to c1 times exponential of negative x plus c2 times the exponential of 2x is the answer, is the explicit answer of this differential equation, because you get only one answer, which all x would be satisfied to be the answer of this equation. Next, we will see what is the implicit solution. For implicit solution itself, whenever we can write down one more answer for any differential equation, we would say that those answers are kind of implicit solution, or if any solution that we just cannot write the function that you can separate the independent and dependent variable out of each other. If you can make it like out of each other, then it is the explicit solution. But if the answer still be like the term that combines both dependent and independent variables, then we would say that it is implicit because it's not explicit. Understand? Understand? Let's see the example. They're saying that we have this relation y squared minus x to the power 3 plus 8 equal to 0 is the solution of this nonlinear differential equation. This one nonlinear. Yeah. This is nonlinear differential equation, right? And then we say that first we got to show that this relationship is the answer of this differential equation. The way that we do it is that put y in there. But the thing is that if you see equation like this, let me write down another way. From this, you would get y, two different answers, right? Because this one is y squared. And then you got to move x to the other side. You would get x to the power 3 minus 8. Now you have y, two value of y, plus and minus, right? Right? Because this is y squared. When you take out the square, you would get two answers, which is plus of the square root of x to the power 3 minus 8. And the other answer is negative of the square root x to the power 3 minus 8. So the thing that you got to do is that if this relationship is really the solution of this equation, so whenever you put the first value of y or the second value of y is supposed to be the answer. It should make this equation right. So we check the first answer first. We check it to see whether this value of y is the answer of this equation. So what we got to do is we just dip it with the x. What we got? 1 over 2 times x to the power 3 minus 8 to the power of negative 1 half times 3x squared. Right? When you dip this with respect to x, you would get this. Okay, and then you plug this one in there to see whether it is the answer. Okay. Are they the same? Are they the same? Is this one and this one the same? The way that I did is just that I find this term, derivative of y with x, which is this, and then I just plug it in. And then I just put the y, this y, in here, and to see whether they are equal. If they are equal, then that means y equal to this one is the answer of this equation. Right? Are they equal to each other? Are they equal? Yeah, they are equal. So that means y is equal to this number, to this function, is the answer of this one. Now we check the other one. The way we do, we just did the same as this. So we make a differential of this answer to the x. What do we got? Negative 1 over 2 x to the power 3 minus 8 to the power of negative 1 over 2 times 3x squared. Right? And then you just plug this one into the equation. You would get this. And then I just put this y in here. Okay, I would get are they the same? Yes. So that means you have two answers for this equation. This one we call implicit solution because you have two. Okay, that is one example of the implicit solution. There's another. This is for this one is saying that if it defines one or more explicit solutions, if you have one or more explicit solutions, so that one we call implicit solution for that equation. Now let's see the other example. They said that show that x plus y plus exponential of the product of f x y equal to 0 is the implicit solution for this equation. But this one is so hard that you can't write y as a function of x. You can't, right? because you always have x and y together. So now it's so difficult to plug this one in to say that it is the answer. But the thing is that is the way to prove. If you do the derivative of this equation, and it turns out that it's equal to this one, that means this is the answer of this equation, right? So I just do the differential for this one with x. I would get using the distribution property. This term, when you dip it, equal to 1. This one, you get exponential of the product of x and y, dxy by dx. And then this one, you use the derivative of the product of two functions. You would get x dy by dx plus y dx by dx. This one equal to y. Now I would put the term dy by dx together. This one and this one, okay? Is it equal to the equation that we have? Is that the same? Yep, it is the same. So that means this relationship is the solution of this equation, right? This relationship is the solution of this equation. But it is not explicit because the way that you write this equation, you just cannot separate y and x out of each other. So that's why it's called implicit solution. Comparing to the explicit solution, it's really clear that this one is the answer. You see, you can write y out of x. Y as a function of x. It's clear. So that's why it's called explicit. But this one is not clear. So that's why it's called implicit.